Hello viewers, welcome once again. In this series, we'll be discussing direct variation. In our former series where we talked about direct variation, we explained what direct variation is. If you have not watched it, you can go and watch it in our channel, where we say that direct variation is when two quantities are related such that an increase in one of the quantity leads to an increase in the other quantity, or a decrease in one quantity leads to a decrease in the other quantity. So that's what we discussed in direct variation. Here we are going to solve problems involving direct variation. This is the first example which we are going to solve in direct variation. Here we have a question on the board. The question says that if W varies directly as T and W is equal to 10 when T is equal to 6, find W when T is equal to 6 and T when W is equal to 15. So let's solve this problem. Solution. We explained that if two quantities varies directly, that is going to be represented in this form, that here we have W varies directly as this other quantity T. And for us to remove this proportionality sign or this variation sign, that we need to introduce a constant at the other side. So if we introduce a constant, we can call that constant K. We will say that W is equal to K times T. So with these that which we have established here, we can now get the value of the constant, because without the value of the constant, we cannot find what we are asked to get. So we'll get the value of the constant and solve the remaining problems. Here we have been given that W is equal to, so we have been given that W is equal to 10 when T is equal to 6. So with this information, we can get the value of K. Now, so we have that from this point, 6 is equal to, 10, the value of W is equal to K times, what is the value of T? T is 6. So we have that 10 is equal to 6K. So with this, we can get the value of K by dividing both sides by the coefficient of K. So if we divide both sides by 6, we will have that 10 over 6 is equal to K. We can equally write this as that K is equal to 10 over 6. Here we can reduce to the lowest term. The common factor here, the number that can divide the numerator and equally divide the denominator, is, we can say that K is equal to, I believe 2 can divide the numerator and equally divide this. If 2 divides 10, we have 5. And if 2 divides 6, we have 3. So we have that K is equal to 5 over 3. We can equally write this as 1 whole number 2 over 3. So with this, the value of K is 5 over 3. We can now solve for W when T is equal to 6. So we have already established that W is equal to KT. So for W when T equals 6, let's make an amendment of the equation. Let's say 6 T is equal to 12 here. So solving for W when T is equal to 12, we'll say that we have already established that W is equal to KT, and this implies that W will be equal to, what is the value of K? 5/3 times, what is T? T is 12. Let's say it over 1. So it means that W is equal to 3 can divide itself 1, and 3 dividing here you have 4. So 5 times 4 will give us 20. So that is the value of W when T is 12. So we can equally solve for the value of W, the value of T when W is equal to 15. So when you solve that, for T when W is equal to 15, applying this on this formula here, we have our W as 15 equal to K. Our K is 5/3, so we have 5/3 T. If we cross multiply, we have, this implies that cross multiplying this is over 1, this times this will give me that 5T is equal to 3 times 15 is 45. And for us to get the value of T will now be equal to 45 all over, dividing by the coefficient of T, which is 5. And this will give us that T is equal to 9. So T is equal to 9 when W is 15, and W is equal to 20 when T is equal to 12. So this is how to solve this variation problem. In our next episode, or another part of this class, we will solve another problem, or probably a Y equation on direct variation. Thank you for watching.